first workshop, and thank you for coming. So for today, we're just going to be working on math fundamentals, which is basic algebra skill that all students, at least at this level, college level, should be able to understand. And solving equation can be as simple as finding the value of x plus 2 equals 8, to solving for x in a trig function, like solving for the value of x of cosine 3x plus 2 sine x equals 35 degrees. So something like that. But to begin with, I want to emphasize that in algebra, specifically in working with skills on solving equations, it's important that you know your multiplication table. It's extremely important that you have mastered the multiplication table by now, because this will help you not just in solving linear equation, but also in some skill set like factoring, which is basically undoing the multiplication process of polynomials. And if you're able to understand prime factorization and factors of basic numbers, similar to what you're seeing right now on the screen, you're gonna have an easier understanding on how those algebra skills work. So I highly recommend that you master your multiplication table, especially prime factorization. Integers or operations on integers is another important skill that you need to understand and master to be able to work with algebraic equations. So in my algebra classes, in my pre-algebra classes, I often tell my students to use the number line, which is what you're seeing right now, to help you, kind of like learning how to ride a bike. When you start to learn how to ride a bike, you use the two wheels on the rear wheel, which is your trainer. So at the beginning, you use that trainer to be able to learn how to balance and be able to bike on your own using the two wheels. And then you take the trainer apart once you have mastered, or once you've gotten comfortable with riding the bike without a trainer. Then it's basically a similar experience when using the number line. So the number line is a good visual on how to understand the concept of the positive and the negative numbers, especially on addition and subtraction of integers. With multiplication and division, the rule is pretty straightforward and easy, so you don't need a number line for that. But for addition and subtraction, where I find most students are struggling on, they need to see the numbers in the number line to be able to solve integers or basic integers like this. So 7 minus 2, this is a basic subtraction rule. So we know that 7 minus 2 is just 5. But for some students, when they are presented with 3 minus 8 or 3 take away 8, they get stuck a little bit and think for a little bit before they answer this problem. But if they know how to use the number line, they know that they would start at positive 3, and positive 3 is somewhere here. I hope the cursor is showing. So positive 3, and then you move 8 units to the left because it's a negative number, or negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. So the answer is negative 5. So that's how you visualize the number line and how it works in addition to subtraction of integers, so that when you're tasked to find values or operations similar to this one, it will be a lot easier. So 9 minus 11, you start at 9 and you go 11 to the left, and the answer will be negative 2. And for negative 2 minus 5, you start with negative 2. So you start here and then you move 5 units to the left. So 1, 2, 3, 4, 5. So you have negative 7. So this is how you visualize the addition operation and subtraction operation of integers, as opposed to memorizing rules, because I understand that most of you were presented with operations on integers by memorizing rules. And one popular rule is that if you're subtracting a bigger number from a smaller number, just proceed to subtraction and copy the sign of the bigger number. Something like that, which I find a little bit more challenging for some students who are not really visualizing it. And to be able to understand integers better, you need to see the number line first, so that when you're asked what is negative 25 minus 50, you know that the answer is negative 75 because conceptually you're seeing the number line in your head without really using the number line. So that's just one important skill that everyone should possess when they want to be good in algebra or in calculus or in trigonometry. And properties of numbers, when we're working with equations, there are two properties of numbers that we are going to be working on, and that would be the additive inverse and the multiplicative inverse. And for this, the additive inverse is basically finding a number that when you add to a certain number will equal to 0. So for example, we have 7, and if I ask you to find the additive inverse of 7, so let's say this. So if we're working with additive inverse, and I'm looking for the additive inverse of 7, that means you need to find a number that when you add to 7 is equal to 0. And that number would be, if you want to answer, tell me if you have an answer. You can unmute yourself, but in this case, the number that you can add to 7 so that it will equal to 0 is negative 7, because 7 minus 7 is equal to 0. So that is how you find the additive inverse. So when you are presented with negative 2, so let's say you're looking for the additive inverse of negative 2. So find a number that when you add to negative 2 will equal to 0, and that number would be positive 2. So this is how the additive inverse property work. You're looking for a number that will make a certain number equal to 0 by finding a number to add it with. Now, if we have an additive inverse, we also have multiplicative inverse, and the multiplicative inverse is basically finding a number that when you multiply to that number will equal to 1. So let's have an example of that. So let's say we have 7. So if you have 7 and you need to multiply 7 with a certain number and it should equal to positive 1, what would that number be? And I find it a little bit challenging for some of my students who are working with algebraic problems for the first time to think of that number, because they always think that when you multiply a number with another number, it will always become bigger, not smaller. So how are you going to multiply 7 so that it will become smaller and it will equal to 1? This is where the reciprocal property will come into play, because if you multiply 7 by 1 over 7, which is the reciprocal of 7, it will equal to 1, because 7 multiplied to 1 over 7, so it's basically 7 over 1 right here. So 7 over 1 times 1 over 7. So we cancel this, and we are left with 1. So that is the multiplicative inverse. So that's why when you think of multiplication, it's to undo the multiplication process, you use division. So this is basically the relationship between those two operations. So if we have negative 2, the multiplicative inverse of negative 2 is positive 1/2, which is the reciprocal of 2, and since we're looking for that negative value, it needs to be a negative 1/2 so that it will turn into a positive 1. So those are the two properties that we're going to be using in working with solving for the equation. So let's say we have this as presented to us as a problem on solving equation. This is basically how algebra is presented to first grade students, or even sometimes in preschool level. So a box plus a number equal to 7. So what is the number inside the box, or how are you going to complete this equation by putting a number inside the box? So this is how algebra was presented to us in elementary school when we are tasked to find the missing number to complete the equation. And sometimes when we use algebra, or the language of algebra, from having a basic box, we change the box into an X. That is why you're often seeing the letter X in an algebraic problem so that we can replace the box into a letter, which is X. Because now we are not only limiting our variable into a single variable, which is a box, and sometimes thinking of shapes can be a little bit limiting. So let's use the alphabet to make or to have a variable that we can use for several ways, such as X or Y or A or B, or basically the English alphabet. So those are the variables. And in this case, if we are asked to solve for the value of X, and the value of X for the first one using the language of algebra, it's going to be a little bit different now, because for this case, if I have X plus 5 is equal to 7, to solve this algebraically, we find the additive inverse of positive 5, and the additive inverse of positive 5 is negative 5. And whatever we do on this side of the equation, we need to also do it on this side of the equation. So if we subtract 5 on this side of the equation, or the left side, we need to subtract 5 on the other side as well. And by doing this, we are eliminating positive 5 by X. So now X is by itself, and 7 minus 5 is equal to 2. So this is basically how the language of algebra shifted from using a box into using algebraic processes similar to this one. So if we're going to be solving X minus 3 is equal to 8 using algebra, we're going to find the additive inverse of negative 3, which is positive 3. And basically, we're balancing equation, because whatever we do on the left side, we need to do it on the other side. So our answer will be X is equal to 8 plus 3, which is equal to 11. So this is how basic algebra works when we are using problem similar to X plus 5 is equal to 7 and X minus 3 is equal to 8, which is introducing you to the process, or the algebraic process of solving for X. So we subtract 5 on both sides, which is X equal to 2, and we add 3 on both sides so that we have X is equal to 11. And that is how we use the additive inverse for the operation of addition and subtraction. But when we are presented with problems similar to this one, what number can you multiply to 5 for it to equal to 45? And what number do you need to multiply to 2 so that it will equal to negative 10? By using this process, we know that we can easily solve this if we know the multiplication table. But in algebra, instead of using a box, we're using X. So we are rewriting it into 5X is equal to 45 and 2X is equal to negative 10. And using the algebraic steps, we're now using a different process, which is presented as this. So if we have 5x is equal to 45, we need to find the multiplicative inverse, because now we're seeing the operation of multiplication, which is 5 times x, or 5x. And the multiplicative inverse of that is 1 over 5. That's the multiplicative inverse of 5. So we multiply both sides by 1 over 5, and this by 1 over 5. So now we know that we can cancel this out, and x is left with 45 all over 5. And since x, or 45, or 5 is divisible by 45, so we have 45 divided by 5, which is equal to 9. So this is how we articulate our algebraic process in such a way that we are truly understanding how algebra works. So we divide both sides by 5, and x is equal to 9. So if we have 2x equal to negative 10, by finding the multiplicative inverse of 2, which is 1/2, we multiply both sides by 1/2, and we cancel this out so that x is equal to negative 10 all over 2, and 10 divided by 2 is equal to negative 5. And another way of presenting this steps, instead of multiplying it with the multiplicative inverse of 2, we can simply do it as 2x is equal to negative 10, which is a more popular way on solving for x. We divide both sides by 2 so that x is equal to negative 5. So this is how we use the algebraic steps in solving problems similar to 2x is equal to negative 10, which is equal to negative 5. So that's how algebra works when we are using the algebraic steps. And once again, since this is a workshop, I'm just trying to emphasize how important it is to understand the concept as opposed to or memorizing rules and procedures in mathematics, because we need to be able to make a connection on how we use math steps like what we're seeing right now from how our brain see it and how our brain is understanding it. And this is how it works when we are trying to comprehend how these crazy algebra steps are done, and it all boils down to the basics. So we need your pen and paper for this problem, because now I want you to practice on these four problems. We have four equations, and for these four equations, x plus 3 is equal to 2, negative 5 plus x equal to 1, 2x is equal to 8, and x all over 2 equals 1. It's only requiring you to use a single step, one step, to be able to solve for this problem. So, take it away. See if you can solve 1, 2, 3, and 4 while I get my water. All right, so let's solve these four problems. Let's start with problem number one, which is really simple. So if I have x plus 3 equals 2, additive inverse of 3, negative 3 on both sides. So x is equal to negative 1. So that would be problem number 1. X is equal to negative 1. And for number 2, we have negative 5 plus x equals 1. Additive inverse of negative 5 is positive 5. And whatever we do on the left side of the equation, we have to do it on the right side of the equation. So this cancels out. So x is equal to 6. So this is our answer for number 2. And for number 3, we have 2x is equal to 8. And we need to find the multiplicative inverse of 2, which is 1/2, or simply divide both sides by 2. So x is equal to 4. So this is our answer for number 3. And for number 4, it might look a little bit difficult because most students develop their math anxiety starting with fractions or learning fractions, but just make sure that you are understanding the rule, which is multiplicative inverse. If that means we have 1/2 or over 2, the multiplicative inverse of that value right here is simply 2 all over 1. So we multiplied by 2 all over 1, or simply multiplying both sides by 2 so that we can cancel out the 2 by x, and x is equal to 2. So this is how we answer problems with fractions. So just remember that when you see fractions in an equation and you need to solve for the value of x, remember that you are just working on or thinking of a number to multiply to the both sides. So that means fractions. Just need a whole number, and you have a whole number, you have the reciprocal. So this is how we solve one-step equation similar to this one. So if we have a more complex problem like this one, we have solving two-step equation. We have problems 1, 2, 3, and 4, and we're going to solve for x for this new problem. So it will require us 2 steps instead of 1. So see if you can solve this problem. So practice on problems 1, 2, 3, and 4, and I'm going to give you 2 minutes to solve this. All right, so let's solve these problems. Starting with problem number 1. For 1, we have 2x plus 3 equals 1. So we need 2 steps to solve this problem. So first, we use the additive inverse. So we always add or subtract first before we divide or multiply, kind of like the order of operations. So we have negative 3 on both sides. So we have 2x equals 3. 1 minus 3 is negative 2. We divide both sides by 2, so that x is equal to negative 1. So the answer here is negative 1. And for problem number 2, we have negative 5 minus 3x equals 2. So we either subtract or multiply first at the beginning. So we're going to get rid of negative 5 right here. Additive inverse of negative 5 is positive 5. So add 5 on both sides. We're left with negative 3x is equal to 7. And then we divide both sides by negative 3. And we are left with x equals negative 7 over 3. And in mathematics, don't think that when your answer is ending up like a fraction, it's wrong, because you are not limited to only positive and negative numbers or whole numbers. Sometimes you can also have fraction as your answer. So for number 2, we have negative 7 over 3. And for problem number 3, we have negative 2x plus 1/3 equals 2 over 3. And again, most students would think that this is an impossible problem to solve. But if you know your fractions really well, this is going to be really easy. By, again, it's addition and subtraction first, so we need to subtract 1/3 on both sides. So we cancel it out. So we have negative 2x is equal to 2 over 3 minus 1 over 3. And this one right here is a simple fraction because the denominators are the same. So if we have a denominator that is the same, we copy the denominator and we subtract the numerator. So 2 minus 1 is equal to 1. So that means we have negative 2x is equal to 1/3. But since we're looking for x and not negative 2x, we need to multiply both sides with the added or multiplicative inverse. And the multiplicative inverse of negative 2 is negative 1/2. So we multiply both sides by negative 1/2 so that we cancel out the 2's and the negatives right here because negative and negative makes a positive. So now we have a positive x times 1/3 multiplied by negative 1/2. And the rule of multiplication for fraction is pretty simple. You just multiply across. 1 times 1 is 1. 3 times 2 is 6. And since this is negative, the answer is negative 1 all over 6. So this is how we answer problems with fractions. Again, don't get too intimidated. That's why it's important to know your math fundamentals, and including in the math fundamentals that you need to have mastered prior to going to any algebra subjects or classes or courses: addition, subtraction, multiplication, and division of fractions. So you need to have mastered those skills. That's why answering number 4 would be easy if you know your fractions really well. So we have x all over 2 minus 2 is equal to 1. So using our rule, we subtract or we add 2 on both sides because that's the additive inverse of negative 2. So now we have x all over 2 equals 1 plus 2 is 3. And now we have x all over 2. So the reciprocal of over 2 is, or 1/2 is 2. So we're just going to multiply both sides by 2 this time so that we can get rid of the 2. Oops. So we can get rid of 2 right here. And we'll have x is equal to 3 times 2, which is equal to 6. So this is how we work out problems involving fractions in algebra. Sometimes it's easy, sometimes it's a little bit difficult. And Leroy or Kiman, how do you want me to call you, Leroy or Kiman? You got stuck on 3 and 4, and that's understandable because, again, as I mentioned, fractions, it's a different beast. And to be able to be comfortable with more problems in algebra, you need to really master the basic of your arithmetic. And that includes fractions operations. And probably I'm going to have another workshop for fractions in the near future. So most of you will be able to answer problems that requires you to work on fractions. And those problems could be this problem. So see, from the 2 examples that I had on the previous slide, which is problem number 3 and number 4, see if that helped you recall your rules of adding and subtracting, multiplying and dividing fractions, and see if you can answer 1, 2, and 3. I'll give you a minute to do this. All right, let's answer 1, 2, and 3. 1 and 2 is actually pretty basic because you'll notice that the denominators are the same. Number 3 can be a little bit more challenging because the denominators this time are different. So let's start with problem number 1. So for problem number 1, we have x minus 2 all over 7 equals 12 all over 7. So the first step that we need to do is to add 2 over 7 on both sides so that we can cancel out the 2 over 7 by x. So now x is by itself, and we have 12 over 7 plus 2 all over 7. And we know that the rule in addition of fractions with the same denominator, you copy the denominator and you add the numerator. So 12 plus 2 is equal to 14. And we know that 14 over 7 can be simplified into 2. So x is equal to 2 in this problem. So there. So it's easy when our fractions have the same denominator when it comes to addition and subtraction of fractions. So let's go ahead and try number 2. So for number 2, we have x plus 3 all over 12 equals 15 all over 12. And just like the first problem, we use the additive inverse of the fraction, and we have positive here, so we have negative as an additive inverse. Negative 3 all over 12 on both sides, so that we can cancel out this, so it will equal to 0, so x is by itself. And now we have 15 all over 12 minus 3 all over 12. And by the rule of fractions, you copy the denominator and you subtract the numerator. And 15 minus 3 is equal to 12. And 12 over 12 is also equal to 1. So x is equal to 1 in this problem. So x is equal to 1. Now number 3 can be a little bit challenging. And the reason why this is a little bit challenging is because now x minus 2 all over 5 equals 3 all over 4. We are subtracting or adding both sides by the additive inverse. And the additive inverse of negative 2 fifths is positive 2 fifths. So we can cancel this. So we are left with 3 over 4 plus 2 all over 5. Now, there are so many rules that was presented to us when we are adding and subtracting of fractions with different denominators. I'm going to show you an algebra rule that I often use. And sometimes they call it the butterfly method. And the butterfly method is simply you multiply the first diagonal, 3 over 5, plus the second diagonal, 2 times 4, divided by the product of the denominator, 4 times 5. So this is how we add and subtract fractions with different denominators. And by simplifying our fractions, x is equal to 3 times 5 is 15, plus 2 times 4 is 8, and 4 times 5 is 20. And by further simplifying it, 15 plus 8 is 23, all over 20. And that is our answer, 23 all over 20 for problem number 3. And again, it's important that when you're working with problems in algebra, you have mastered your basic. And the basic would be the multiplication table, the number line for adding and subtracting of positive and negative numbers, and fractions. And fractions can be a little bit challenging for most students, and I can understand why. So it's all about practice and making sure that you are understanding fractions better through examples. So before, or if you want to get rid of your math anxiety when it comes to algebra, my best advice is for you to master fractions. And to do that, there are a lot of math videos, YouTube videos, even TikTok videos that teach you and give you techniques on how to understand fraction better. So practice on that, master that, so that when you go to algebra, trigonometry, statistics, calculus, um, solving problems involving those subjects or math classes will be a lot manageable because you have mastered the basic and you're not gonna need to spiral and work on the basics of math fundamentals to be able to understand the complex questions in those math classes that I have just mentioned. So once you have mastered your fractions, you'll be able to understand these problems. So these are some problems on multiplication, division, addition, subtraction, and fractions. We're not going to be working on that. Probably on the next workshop we will, but for now, that's the basic of solving for equation. And hopefully I'll be able to see you again on my next workshop really, really soon. Leroy. Um, Kiman.